This is the 1-4 Distributive Property Study Guide and Intervention, the pink sheet that we did in class. On this one, we're talking about the distributive property, which says that if you have a number outside of the parentheses, it gets multiplied to the other ones. Inside the parentheses, you can either break them up or put them together. And so in the first one, it kind of looks like, well, we're not going to use the distributive property. But remember that distributive property is to enable you to do mental math a lot quicker and easier. So I might not know what 20 times 31 is, but I do know what 20 times 30 is and 20 times 1 is. So I'm going to substitute in, and that's from our previous section, substitution. If something is equal to another thing, I can put it into the equation. So 30 plus 1 is equal to 31, and now I do have a number outside the parentheses of things being added or multiplied or subtracted together. So this was a substitution. Now I'm going to use the distributive property and actually multiply the 20 by both things. That's a 30 inside the parentheses. And then again, 20 times 30, 2 times 3 is 6, and then I have 2 zeros after it. I count up my zeros. And then 20 times 1, well, that's the multiplicative identity. Anything times 1 is itself. And then 600 plus 20 is 620. And again, we're showing all these steps now. It's important to show the steps now, but ideally, you'll get good enough that you could do these in your head. Okay, in the next one as well, it doesn't look like a distributive property problem, but recognize that a fraction, like 4/2, actually means 4 plus 1/2. So we're going to rewrite that as 12 times 4 plus 1/2. And now again, we have a distributive property. So I'm going to write that out, where the 12 goes and multiplies by both things inside. So 12 times 4. And then keep the operator in between. So plus 12 times 1/2. 12 times 4. 10 times 4 is 4. 2 times 4 is 8. 10 times 4 is 40. 2 times 4 is 8. So that's 48. And then plus half of 12 is 6. 48 plus 6 is 54. And again, show all the steps now so that later you can get to be good enough to do it all in your head. The next one, we're going to break up 311 into what we know easily. So I know what 5 times 300 would be, because I know what 5 times 3 would be. And I know what 5 times 11 would be. So I'm going to break up 311 into 300 plus 11. And that's just a simple substitution. Then I'm going to use the distributive property to write it out. Five times 300, I do 5 times 3 is 15. And then count my zeros. I have 2, so I put 2 at the end. 5 times 11 is 55. And then I add those together, so I get 1,555. All right. In the next one, we actually have a distributive property right off the bat. So I'm going to multiply the 5 by 4x and the 5 by 9. And remember, this operator in between stays the same. So I'm going to have 5 times 4x minus 5 times 9. And when I multiply a number by something x, the numbers are what gets multiplied. So I'm going to have 5 times 4 is 20x minus 5 times 9 is 45. And since they didn't tell me what x equaled, then this is as far as I can go because I don't have any like terms to combine. Remember, a like term has the same variable and the same power on the variable, which is not the situation I have here. Number 3, we're going to do much the same way. Distribute the 3 through. So I'll have 3 times 8 minus 3 times 2x. 3 times 8 is 24. Minus 3 times 2 is 6x. And since 24 has no variable and 6x has x, that's as far as I can go. There's no more like terms. And the last one on this page here, number 6, doing it much the same way. 12 times 6 minus 12 times a half x. Twelve times 6, well, 10 times 6 is 60, and 2 times 6 is 12. 60 plus 12 is 72. And then half of 12 is 6. Still have the x. That's as simplified as it gets. Still doing the same sort of thing on number 7. 12 times 2 plus 12 times a half x. 12 times 2 is going to be 24. Half of 12 is 6. Number 8, multiply that 1/4 through. And remember that when you multiply by a fraction like that, it means to divide it by the number that's the denominator. So 12 times 1/4, or 1/4 times 12 to be consistent, minus 1/4 times 4t. So 12 divided by 4 is 3, or 1/4 of 12 is 3. And then 1/4 times 4, this is the multiplicative inverse property, because 4 can be written as 4 over 1. 1/4 and 4 over 1 are reciprocals, so I end up with 1t. And just by math conventions, I don't actually leave a number 1 in my simplified writing. If it's 1t, I just write it as t. So I would write this as 3 minus t. And the next one, 3 times 2x, 3 times minus y, minus 3 times y. 3 times 2 is 6x, minus 3y. Since they have different variables, I can't combine them, so that's as simplified as it gets. In number 10, we have more than 2 in our parentheses, but it still just goes the same way. You could have 50 things in the parentheses, and you just multiply the one outside by the ones that on the inside. So I have 2 times 3x plus 2 times 2y plus 2 times negative x, or minus 2 times z, excuse me. So 2 times 3x plus 2 times 2y minus 2 times z. 2 times 3 is 6x. 2 times 2 is 4y minus 2z. X, y, and z are not the same variable, so I can't combine any of those. And that's as simplified as I can make it. In number 11, we have the number being multiplied on the right side. It doesn't make it any different. You still do the same thing. So I could easily write this as y out front if you're more comfortable with that. And then the y gets multiplied by the x and the 2. So I have y times x minus y times 2. And in math, they typically write things alphabetically when it's variables being multiplied. So instead of having yx, they would write xy. And we know by the commutative property that in multiplication order does not matter, so I can switch those around. And then we'll always write the number before a variable as well. So we would write y after the 2. So 2y, not y2. And since x, y are next to each other in this term, and there's no x in this one, we can't combine them. This is as simplified as you can get. We again have 3 inside the parentheses, so 2 times 3a, 2 times 2b, 2 times c. And you just always keep whatever operation is going on in between them. So 2 times 3a makes 6a, minus 2 times 2b is 4b, plus 2c. Since we have a, b, and c as our variables, and none of them are the same, that's as simplified as I can get. On the last ones on this page, we have 1/4 out front. And remember, when we multiply by a fraction, it's the same thing as dividing by the denominator. If the number's a 1 on top, I should say. So I have 1/4 times 16x minus 1/4 times 12y plus 1/4 times 4z. Well, 1/4 of 16 means dividing 16 by 4, which is 4x. 1/4 of 12 is 3. 12 divided by 4 is 3y. And then 1/4 of 4, again, those can be considered reciprocals, which gives me a 1. But we don't ever write a 1 if it's a coefficient. So we would then rewrite this as 4x minus 3y plus z. And since they all have different variables, we can't combine them any further. In number 14, we have the number to the right. It does not matter. It still gets multiplied by everything. So 3 times 2 minus 3 times 3 x plus 3 times x squared. 3 times 2 is 6 minus 9x plus 3 times x squared. Now, since x and x squared don't have the same exponent, even though they have the same variable, they are not like terms, and that's all the farther I can simplify. Number 15, I have to take the negative with the 2. So negative 2 times 2x squared, negative 2 times 3x, negative 2 times 1. And I'm just putting the negative 2 here and here in parentheses to remind us that it's a negative 2 being multiplied, because it gets a little confusing with the plus sign right next to it. So negative 2 times 2 is a negative 4x squared. Negative 2 times 3 is negative 6x. And then negative 2 times 1 is negative 1. So when I'm adding negatives, I put them in parentheses. And now I'm going to simplify because I can't have parentheses in the end. So adding a negative is the same thing as subtracting. So I have minus 4x squared, and then I'm adding a negative. So it's really just subtracting that term, 6x. And then plus negative 1 is the same thing as minus 1. All right, on the back side, it says simplify each expression. If not possible, write simplified. On the back side, we might use the distributive property forwards, and we might do the reverse of the distributive property. So for instance, on the first one, there's no parentheses for us to multiply through, but we're going to work backwards with the distributive property. And we're going to say, well, this must have come from, or could have come from, if the a was out front, and then I had 12 minus, remember, I don't write it here, but there's an imaginary 1 right there. So 12 minus 1 is 11. I have a times 11. And then I always write the variable in, behind the number, or the number in front of the variable. So that I would write as 11a. That's my final answer. On the back side, I have, on number 2, I have a similar problem. They both have x, so I could write that, I could pull it out, and then that would leave the 3 plus 6. So you can kind of see how this is the reverse of the distributive property. If I was to then work this out by the distributive property, I would have 3 times x and 6 times x. So that's my original one. And the reason that I do that then is I can just add these two numbers. 3 and 6 are 9. So I have x times 9. And then I write the number in front of the variable for 9x. Number 3, I have an x and I have a constant, or a number without a variable. They are not like terms, I can't combine them. This is already simplified. In number 4, I have 3 terms, but only 2 of them are like terms. I have 20a and 12a. 8 doesn't have an a with it, so I can't combine it with anything. So I'm going to take the 20a and 12a, and just like I've done in number 1 and 2, I'm going to pretend like the a must have been out front, and that leaves me with 20. The operation in between is plus 12, and I still have minus 8 at the end. 20 plus 12 is 32, so a times 32 minus 8. And then I would rewrite that with the number in front of the variable, 32a minus 8. In number 5, I have x squared as this variable and x squared as this one. So I'm going to combine both of them just like I've been doing. I'm going to pull out that x squared in front, and then I have 3 plus 2 left. And you can see if I was to multiply that out, I'd have 3 times x squared plus 2 times x squared if I use the distributive property forwards. So I'm going to add 3 and 2 to get 5. So x squared times 5, and then I write the number in front of the variable. And that's as simplified as I can get. Number 6, I have x, and then x squared and x squared is my variable. The x doesn't have the exponent of a 2, so it can't be combined with the x squareds. So it'll have to stay outside. So 6 minus 6x, and then I'm going to pull out the x squared, like I've been doing, and 3 plus 10 I'm left with, because I could multiply that through and have 3x squared and 10x squared. I'm going to add 3 and 10 to get 13. And my last step, I'm going to move the number in front of the variable. And again, the x that's next to the minus 6 doesn't have a squared, but the x that's next to the 13 does, so they are not like terms, they cannot be combined. Number 7, I have 2p and 1/2 q. They are not the same variable. I cannot combine them, so 7 is already simplified. Simplify. And number 8, there's a couple of different ways you could do number 8. The way that I'm going to show you is that you would do the distributive property by multiplying the 4 through. But remember that a minus means the same thing as a plus, a negative. So I'm just going to rewrite this to remind ourselves of that, to keep those straight. So I'm going to have 10xy plus, and then I'm going to do a negative 4 times xy plus xy. Okay, so when I multiply that 4 through, it's actually a negative 4 going through. So 10xy is not part of this distributive property yet. And then I'm going to say plus negative 4xy plus negative 4 times xy. So I have negative 4xy plus a negative 4xy. That's going to give me negative 8xy. So I have 10xy plus negative 8xy. Whoops, don't need that parentheses there. And then I'm going to do the reverse distributive property and pull out xy since they both have them. And then I have 10 plus negative 8. And 10 plus negative 8 is the same thing as 10 minus 8, which is 2. So I have xy times 2. And then my last step would be to write the number in front of the variable or variables. So I would be left with 2xy. Number 9, I have 21a, 18a, 31b, minus 3b. So I'm going to do two different distributive properties. So I'm going to pull out the a from 21 and 18. And then I'm going to pull out the b from 31 minus 3. So really look and pay attention. If I were to distribute this through using the distributive property, make sure that you can see how you would end up with our original problem that they gave us in number 9. So 21 plus 18 is 39. So I have a times 39. And 31 minus 3 is 28. So I have b times 28. And the last step is to write the number in front of the variable. 39a plus 28b. Since they're A and B, they can't be combined. Alright, in number 10, we have 4x and then 1/4 times 16x minus 1/4 times 20y. So 4x stays the same, plus 1/4 times 16x minus 1/4 times 20y. So 1/4 of 16 is the same thing as 16 divided by 4, that's 4x. And then 1/4 times 20, 20 divided by 4 is 5y. Then I'm going to do the reverse distributive property and pull the x out from the 4x plus 4x. And then I have 4 plus 4. 4 plus 4 is 8. And then the last step is to write the number before the variable. Number 11. Looks like I can't simplify it because the variables that I have are x and x squared. They can't be combined, but I can do the ones that don't have variables. So that's a pretty simple thing. 2 minus 1 is 1 minus 6x plus x squared. And that's it. Now I have something without a variable, something with a variable x, and something with a variable x squared. They're not like terms and there's no more parentheses, so it's simplified. And the last one of this section, 4x squared plus 3x squared plus 2x. Well, x squared, and x. I can combine the ones that have x squared. And I do that by doing the opposite of the distributive property, pulling it out. And you should be able to see if I multiplied that x squared through, I would end up with my original problem. 4 plus 3 is 7. And then write the number before the variable. And that is it for that section. All right. The last two are word problems. And it kind of practices what we've been doing in terms of section 1-1, which was writing and evaluating expressions, and then we did, writing expressions, and then evaluating expressions, and then using properties of numbers, and now the distributive property. So we write the algebraic expression and simplify and indicate the properties that were used. So we have 6 times the difference of 2a and b. So the difference of 2a and b, I would write as 2a minus b. And it wants 6 times that. So it's basically setting up a distributive property problem. And then it says increased by 4b. So that means at the end, I'm going to add 4b. So the first thing I'm going to do is use the distributive property and multiply that 6 by both things. So 6 times 2a minus 6 times b plus 4b, and that's the distributive property. I'm just going to write dist. Then I'm going to actually substitute what 6 times 2 is, and that's 12. So 12a, that was the substitution property. Basically putting in something that is equivalent. Then I'm going to do the reverse distributive property with the 6b and 4b. So I'm going to have 12a minus, and then the b is going to be out front, 6 plus 4. So that again is the distributive property. Six plus 4 is 10. And that's substitution, putting in what it equals. And then the last step is just to rearrange. So 12a minus 10b is the commutative property. All right, the last problem says 2 times the sum of x squared and y squared. So the sum of x squared and y squared I would write as this, x squared plus y squared. And then I want 2 times that. That's setting up another distributive property problem. And then it says increased by 3 times the sum of x squared and y squared. So I'm going to have x squared plus y squared. And I want 3 times that sum now. So in this one, I actually have kind of a funky looking common common term. This is the exact same for both of them. So I can actually pull it out front and say that I have x squared plus y squared, and then 2 plus 3. Well, 2 plus 3 is just 5. So this is the distributive property. 2 plus 3 is 5. That's going to be substitution. Then we're going to distribute this number through so that I have 5 times x squared plus 5 times y squared. And then I just rewrite without the, so that's the distributive property, and I rewrite without the multiplication symbols. And I have 5x squared plus 5y squared.